Welcome to this presentation about Pick's rule. Pick was an Austrian mathematician who discovered this property in 1899. Now look at the screen. We have a grid and we have a square drawn in the top left-hand corner. Assuming that they are centimetre squares, what is the area of that square? Obviously it's 1 square centimetre. What about the second shape? We can subdivide it, of course, into square centimetres and then take into account that we have triangular sections, and it's not too hard to figure out that the area is going to be 8 square centimetres. Here's a slightly more challenging one, but again it's quite possible to divide that into triangles and squares and work out the area. In this case it's 4 square centimetres. What about this one? Quite a deal more challenging, isn't it? I guess if you had enough time you could divide it up into triangles and squares and add them up and get a final answer, which will be 42. Now I didn't do it that way. I used Pick's rule, which is a very simple way of doing it, and it involves counting the dots on the shape. Let's see how. This is Pick's formula. To work out the area of the shape, you work out half of the number of dots on the perimeter and add to it the number of dots that are inside the shape, and then minus 1 from your result. The proof of it is quite challenging, so I'll just give you a brief idea in a couple of simplified cases. Let's suppose we start with our original square. That has 4 dots and the area is 1. If we then extend that and make 2 squares, then we have 6 dots and the area is 2. Add a third square and we have 8 dots, the area is 3, and let's do it once more. 4 squares, 10 dots altogether, and the area is 4. Is there a pattern between the number of dots and the area? Yes, there is. You can see that the area can be found by having half of the number of dots and then minusing 1, which is a simplified or watered down version of the formula. Let's try extending it in a different way, where we now include dots on the inside. We'll start with that larger square. It has 8 dots on its perimeter and 1 dot inside. The area is 4 square centimetres. Extending that now, we have 10 dots on the perimeter, 2 dots inside, and the area is 6. And once more, 12 dots on the perimeter, 3 inside, and an area of 8. Can we find a relationship between the dots and the area for this one? It's actually Pick's rule, isn't it? It does work, and you can check that by substitution. Now let's apply the formula to our quite large shape, the green one that you can see. If you count carefully, you'll find that there are 46 perimeter dots and 19 dots on the inside. And using our formula, we get an answer of 42 as we expected. Now let's try a software program that I've developed that would allow us to create these sort of shapes and work out the area using Pick's rule. When you open up the program, this is the main screen. It consists of our grid of dots and the options are underneath. Border means how many dots will be on the outside of the shape. Inside will count how many dots inside the shape. Clear means to start a new shape. Info gives you some information about the activity, and you have a choice of whether or not you want sound. What you do next is to use your mouse pointer to create your shape. Let's say I start here. Click on the dot that you want to start at, and then click on another dot, let's say here, and you can see that a straight line connects them, and you keep going like that until you create the size and shape that you like. Now if you try to overlap, you will not be allowed to do it because intersections are not open shapes that we can work out the area. So let's just create a shape there. I'll try to make it a bit interesting and challenging at the same time. So possibly something like that. And I think we're nearly there. Now remember, you must connect the last point of visit to the start, which is here. And once you've done that, have a look and see what happens.
Now, press the area button for the answers.
The outside of the shape has been shaded blue, and we can see the outline of the shape, and Down here where it says border, it says that there are 39 dots on the outside of the shape, 129 dots on the inside, and to work out the area using Pick's formula, we click area.
There are 39 points on the border, 129 points inside, and the area is 147½ square units. Press the clear button to try again.
And there you have it, a simple demonstration of Pick's rule in a visual way. I hope you find it interesting. Please download it and try it for yourself from my website, www.emathame.com. Until next time, bye-bye.